Well, good morning, everyone. Today we're going to look at a topic from Chapter 6, Remember Fractions. We're going to focus on solving rational equations. So the first kind of rational equation are ones that essentially just have fraction terms. So for instance, if you had x over 7 plus 2 over 14 equals x over, say, 21, and you wanted to solve such an equation, it's got fractions in it, therefore technically it's a rational equation. And the way you would solve a question like this would be, for the most part, the same techniques that you would typically use in any equation, and that is the one that I call as long as you do it to both sides is okay rule. So I'm going to subtract x over 21 from both sides and subtract 2/14 from both sides. Now I could call that 1/7, but it doesn't actually matter. Then I have the issue that I have these two fractions here, both containing x's and another fraction over there, and I want to combine these two together. So I want you to pull out x as a common factor. And you get that. If you want to take 1/7 and 1/21, you go 1 divided by 7, then you subtract 1 divided by 21, and then you hit math button, choice 1, and you get the answer 2 21s. So what you've really got here is x times 2 21s is equal to, let's simplify that thing down to there. Now to find x, all you need to do is divide both sides by 2 over 21. And again, the calculator is going to do most of the heavy lifting. So negative 1/7, negative 1/7, divided by, put a bracket around it, 2 21s, and then math, fraction, enter. And the final answer is negative 3/2. And this has done our first example of solving a relatively simple rational equation. Now, the next kind of question is going to just have a little combination of 2 over 3x take away 7 equals 5. Now, if you have a single fraction equal a number, or a single fraction equal another fraction, so it's that kind of format, what you can do is you can rewrite this guy as 5 over 1, so you now have two fractions. And then you do a technique that is called cross multiply, which basically means that you're allowed to multiply opposite numerators and denominators together. And there's a theory that says that these will be equal. So 5 times 3x take away 7 equals 2 times 1, which is 2. You then can distribute the 5s. You can then add 35 to both sides. And finally, you can divide both sides by 15. And if it is possible, you should simplify that fraction. But this particular one doesn't simplify, so we don't need to do anything. Now, a more difficult version of that would be something like 4x plus 1 over 3 equals 2x minus 2 over 5. So in this situation, you're going to have a fraction equals a fraction. And when that happens, you can go straight into the cross multiply. And what we're going to have is 5 times this one is equal to 3 times that. So what we essentially are doing is trying as quickly as we can to remove the fractions from the problem. So we no longer have fractions to deal with. So this fraction equal that fraction translates into this, which is much easier to deal with. 5 times 4 gets you 20x plus 5. And 3 times 2x gets you 6x, take away 6. Then I will subtract 6x from both sides. I will subtract 5 from both sides. And then to finish, I will divide both sides by 14 and check if I can simplify the fraction, which I know we can't. So we are essentially finished. Now, sometimes you will get, as we've seen in the applications, two fractions might be equal to each other as they are here. But when we do the cross multiply, things are a little bit messy. Just put a little bracket around that and that. You're going to multiply these two together. And then multiply these two together and you get 6. So the cross multiplication process has get rid of the fractions that were originally here and what we've translated it into this format. So if we FOIL this, we get x squared take away 2x plus 3x take away 6 is equal to 6. And if you combine the x's, you're looking at that. Now, the minute you see an x squared like this, you are talking quadratic equations. Quadratic equations are best served like that. Called it standard form. So I'm going to subtract 6 from both sides. And in this particular case, I know I can factor, so I will do that. And it's two numbers that multiply together give me negative 12, but when you add them, you get 1. So that would be a plus 4 and a negative 1. This one, this factor gives me the solution that x equals negative 4 will work. And this one gives me x equals 1 will work. And I could check either of those pretty straightforward. So let's check this one to see that it works. So you start off with your original equation before you did anything to it. And you put in negative 4 for x. So you get negative 4 plus 3 over 2 on the left-hand side, which ends up being negative 1/2. On this side, you do the same thing. So it's 3 over negative 4 take away 2, 3 over 3 over negative 6, and that gets you also negative 1/2. And so we've checked it. And the reason that you should do this, not only just to check that you can have an answer, but just in case you have a solution that doesn't work, because sometimes you get a value of x that the equation says works, but that doesn't mean that you can actually get a solution. And let's try another one. Suppose you get 14 over 2 take away x, and you get 2 over x. Right, we do the cross multiply. 14x, 2 lots of 2 take away x. Distribute the 2's. Add 2 to both sides. And then divide both sides by 16. And in this case, it does simplify to a quarter. So you may not get a solution that that simplifies. In this case, it does. Let's see if I can find something else. How about one of these? Bracket round everybody. You have an x minus 9. You have a 2 lots of x minus 5. Distribute, you get x squared minus 9x. Distribute, you get that. I can see an x squared there, so I know I'm going to be dealing with a quadratic. So I will subtract 2x from both sides and add 10 to both sides. And we now have a quadratic It looks like this. I'm going to see if I can factor it first, which would be the best. And I am looking for two numbers that multiply together give me plus 10, but when I add them, I get negative 11. And I get those two. Yeah, well, that works. This factor will equal 0 when x is 1, so there's one of my solutions. And this factor will equal 0 when x equals 10, and there's my second solution. And we are done. So see what other combinations you might get. How about this one? 3 take away 1 over 2x minus 3 is equal to 2 lots of 2x minus 3. I'm going to add this fraction to both sides. So 1 over 2x minus 3 added to both sides gets you 3 over 2x minus 3. I can then make that over 1, and now I can do my cross multiply. Going this way, going that way. We have 6x take away 9 is 3. If you add 9 to both sides, and then divide both sides by 6, that is your solution. So provided these fractions share the same common denominator, you can add and subtract them very easily. So what do we do when we get a combination that are not the same? So suppose I get 4 over x plus 2 over x minus 1 equals 5. Well, adding two fractions together when the denominators are not the same is quite difficult to do. And you'd need to find the lowest common multiple, convert the fractions so that they share a common denominator, and so on. And what I'm going to do instead is a kind of adaptation of that solution method. What I'm going to do instead is multiply both sides of these equations by a term that removes the fractions. Now you can do it in two ways. You can do it one at a time. I don't want that x to be there anymore. So if you multiply all of this side by x and you multiply the other side by x, then you've done nothing. You've only changed the way the thing looks. You've not done anything that changes the information. So that's allowed. Now, if you multiply this, you get 4. If you multiply this by x, you get that. So I've kind of slowly unpeeled the onion. I've got rid of one level. I still have this x minus 1 to get rid of. So what I'm going to do is multiply both sides by x minus 1. As long as you do it to both sides, it's okay. Now, x minus 1 times 4 just gets me 4 lots of x minus 1. And x minus 1 times this fraction just gets me 2x. And while I'm at it, I'll distribute that side. Distribute the 4. And I hope you see a quadratic equation appearing. Right, that guy. Combine like terms. And now I'm going to subtract 6x from both sides. And so add 4 to both sides. And we have this equation now. I'm trying to see in my brain whether I can make this factor. And it has to be two negative numbers, which doesn't really give me much to work with. So I'm pretty sure it's not possible to do it that way. So what I'm going to do instead is A can be 5, B can be negative 11, and C can be 4. And I'll use the quadratic formula. So that's going to be b squared minus 4ac first. So negative 11 squared, take away 4 times 5 times 4. Let's see what we get here. We get negative, in brackets, negative 11 squared. Take away 4 times 5 times 4, and that gets me 41. So we'll continue with the quadratic equation, and x is negative b plus or minus b squared take away 4ac all over 2a. And that gets me the negative of this guy is 11 plus or minus the square root of 41 divided by 2 times 5, which is 10. So we'll now get two solutions. 11 take away the square root of 41 over 10, and the other one is 11 add the square root of 41 over 10. I'll try and make this a little bit nicer, but really there's not much you can do except separate them out. And so your solutions, your exact values for the solution of those two guys. And we'll do one last one of this type, and that should be us covered. So let's do 5 over 2x plus 1 take away 6 over x take away 2 equals 2. So I want rid of that fraction and that fraction. So I'm going to multiply both sides by 2x plus 1. Now there's a slightly quicker way of doing this where instead of doing these multiplications one at a time, you do them as one really big multiplication. But this will do. This guy times this guy gets you 5. This guy times this fraction gets you 6 lots of 2x plus 1 over x minus 2. And this guy gets you what? 4x add 2. Now what I'm going to do is multiply, because I want rid of this guy now, multiply both sides by x minus 2. Well, this guy times this guy gets you 5 lots of x minus 2. This guy times this guy gets you negative 6, 2x plus 1s. And over here you get a quadratic, well, it will be a quadratic, but if you FOIL it, you get 4x squared, take away 8x, added 2x, take away 4. I'll distribute this, you get 5x, take away 10. Distribute the negative 6 and combine some like terms here. We're looking at that. Now combine some terms here, you get that, combine these, you get that. And so we are now looking at a quadratic equation. Add 7x to both sides. Add 16 to both sides. We're looking at this quadratic. So all I need to do now is solve when is this fella equal to 0. I could try and factor it. I can't see one, so I'm just going to do A is 4, B is 1, and C is 12. And B squared take away 4AC gets me 1 squared take away 4 times 4 times 12. And I already know something interesting is going to happen here. Let's show you what. You're going to get 1 squared, which is just 1. Take away 4 times 4 times 12. And the answer is negative 191. Now, why that is interesting is that this means that there's not going to be any solutions to any real number solutions to the problem. because there's negative b plus or minus the b squared over 2a. Now, if I put in the b, all I get is negative 1. I still have this negative the square root of negative 191. And that guy, the fact that that's negative means there's no real solutions. So in this particular equation, there wasn't even a solution. But in another combination, this quadratic may well have solved, and you would end up with 2 distinct answers, and that would be fine, and you would be finished. So hopefully that is of use, and bye-bye for now.